So this next one says to solve and check for extraneous solutions. It's 3 over x plus 2 minus 1 over x plus 2 equals 1 over 5x. So it says solve, so we're going to go about it in a pretty basic way. I can do stuff to this left-hand side. They both have the same denominator, so I'm just going to subtract across the top. So I get 2 over x plus 2 equals 1 over 5x. Now this should look very, very familiar to you. This should look like something called proportions from way back in Algebra 1. So the way we solve proportions is we multiply the diagonals because they've got an equal sign in between them. So I'm going to do 2 times 5x, which gets me 10x, and 1 times x plus 2, which gets me x plus 2. Now I'm just going to go ahead and solve this like normal, so I'm going to subtract x from both sides to get them on the same side. So I get that 9x equals 2. If I divide both sides by, 9, I get that x equals 2/9. Or if you did this in a calculator, you get 0.2 repeating. So that's all well and good. We solved it, right? It's just get it down till you have a proportion and multiply the diagonals in order to solve. But now this is a little bit weird because you'll notice that it said check for extraneous. Now from radicals, you should remember that extraneous means a solution that if you plug it back in, it doesn't work. Now this is going to be a little bit nicer. You could plug the whole thing in and check that this side does in fact equal this side, but we can exploit a little property from functions and domains in that the only way that this would be an extraneous solution is that if we plugged it into any of these bottom terms here, we'd get 0, right? You're not allowed to divide by 0, so if you plug this in and you get a 0 on the bottom, you end up with an extraneous solution. So let's check this side's bottom first. I got x plus 2, or in other words, 2/9 plus 2, which comes out to be 2.222 repeating. That is not 0. That is a happy face solution. If we try 5x, so 5 times 2/9, we are going to get 10/9 or 1.111 repeating, which is also not 0. This is also a happy face solution. So this is not an extraneous solution. This is the solution.